Hi everyone, welcome back to my channel. In today's video, we will be designing a true single phase clock or TSPC D flip-flop using Cadence Virtuoso. So this is a popular type of flip-flop used in high-speed digital circuits due to low power consumption and simplified clocking mechanism. So first, let us understand about the single phase circuits. Then we will understand what is a single phase latch. Then we will see what is the TSPC latch and the difference between single phase latch and TSPC latch. And we will also see the operation of TSPC latch. Finally, we will go to the implementation of TSPC-based flip-flop using Cadence Virtuoso. So in a single phase circuits, we can see that we use two latches with opposite characteristics. So this is first latch and this is second latch, and they are having opposite characteristics. So when phi equal to 1, this latch is in evaluate mode, and when phi equal to 0, this is in opaque mode, whereas exactly opposite happens to this latch. So one latch is transparent while other is opaque at any clock value. Now let us see the single phase positive latch. So you can see here this clock is applied only to the NMOS FET. So when clock is equal to 1, both these NMOS FET will be active or on. So the circuit will be like a cascading of two inverters. So whatever is the input, it will be equal to the output after some transient delay. So the output will be equal to input after the transient delay. So whatever the delay of this inverter and the delay of this inverter, these two will add up and we will get the output after that delay. But when the clock switches to 0, this NMOS FET will also be off and this NMOS FET will also be off. So this will be opaque, means whatever the change is, input will not be reflected at the output. So that is called as opaque. So this is a single phase negative latch. So the only difference is that the clock signal is applied to the PMOS FET. Now look at the true single phase clock latch. So here first we will understand the difference in the circuit of single phase clock and TSPC clock latch. So here you can see the input is applied to this NMOS and the clock is applied to this PMOS and NMOS. Whereas in single phase, the clock was applied to the NMOS and the input was applied to this PMOS and NMOS. So exactly opposite happens in TSPC and single phase. So it accepts the input D using the NFET. So whatever is the input, that will be accepted through this NFET. And the second stage is also a clock control NFET. So this NFET is controlled by your clock. So it uses the concepts of precharge and evaluation. So let us understand the operation. So first, when clock equal to 0, then it is called as opaque state. So when clock phi equal to 0, then this PMOS will be active because its gate voltage is 0, whereas this NMOS will be off because its gate voltage is 0. So this PMOS is active, so it will charge this capacitor to VDD voltage. So remember, this is called as precharging. So when this capacitor charges to VDD, it is a high voltage, so this PMOS will be off. If this PMOS is off and this clock signal phi is 0, then it means that this NMOS M2 is also off. So both MP2 and M2 are off. So MP2 and M2 are always off when V1 is equal to VDD. So it means that the output node is cut off from the power supply. So this V out is cut off from the power supplies because both this M2 and this MP2 and M2 both are off. So the output will be in high impedance state because it is not connected to anything. This also has infinite resistance. This also has infinite resistance. So this output will be in high impedance state. Now when clock equal to 1, so when phi equal to 1, we can see that this MP1 is off and this capacitor was pre-charged to VDD. So this is pre-charged to VDD. So MN2, this will be on because this voltage is VDD. This VDD is applied to the gate of this NMOS. So this MN2 will be active and this MP2 will be off because again the gate voltage is high. So this PMOS will be off. Now clock phi equal to 1. So this M2 will be on. So if this M2 is on, it means that this output capacitor will discharge to 0 volt through this loop. So this C2 is connected to ground through this M2 and MN2. So if Vin is equal to 0 volt, then we can see that the M1 will be in cutoff and this C2 will be discharged to ground. But what will happen if this Vin is equal to VDD? If this Vin is equal to VDD, then we can see that this V1, if this V1 is equal to VDD, then this M1 will also be on and this MN1 will also be on. So this capacitor will get discharged to ground because both these transistors are on. So there is a direct path from capacitor to ground. So earlier it was pre-charged to VDD when clock was equal to 0, but when clock equal to 1 and Vin equal to VDD, then this capacitor will get discharged to 0 volt. So if it is getting discharged to 0 volt, then it will mean that this MP2 will be on and MN2 will be off. Because this voltage is 0 volt, so this PMOS will be on and this NMOS will be off. So this output capacitor C2 will get charged to VDD through this on PMOS. So here output will be equal to VDD. So when Vin equal to 0 volt, then this capacitor will discharge to ground through this M2 and MN2, and when Vin equal to VDD, this capacitor will get charged to VDD through this MP2. So we can see that the circuit operates as a basic latch, that is opaque when clock equal to 0 and transparent when clock equal to 1. So when clock equal to 1, then this Vin will determine the output voltage. So now we will go into the Cadence Virtuoso environment and see the operation of the D flip-flop, TSPC-based D flip-flop. So let us look at this is the design of the TSPC-based D flip-flop. So here we are using 5 PMOS and 6 NMOS, and here we are getting the Q bar output, and here we are getting the Q output after giving the Q bar output to another inverter. So this is just these two PMOS and NMOS are just acting like a static inverter and producing this inverted version of Q bar called as Q output. So let us look at the simulation results. So here we can see when the clock goes to 1, the D input is 0. So the Q output also goes to 0 and Q bar is 1. Then here when the clock goes to 1, the D input was 1. So the Q output also goes to 1. Here when the clock goes to 1, the D input was 0. So the Q output also goes to 0. Here when the clock goes to 1, the D input is 0. So the Q input is also 0. And obviously Q bar is the inverted version of Q input of Q output. So here we can see for complete design, we have simulated the results. Thank you. Please like and share the video and subscribe the channel for more such videos on Cadence Virtuoso. Thank you.